Welcome to qnawire.
For the first item, we have to use the equation for the magnitude of the gravitational force, which is the following. The magnitude is given by Newton's constant times the mass of the first object times the mass of the other object divided by the distance in between them squared. Then, using the data given by the problem, we have 6.67 times 10 to minus 11 times the mass of the Earth, which is 5.98 times 10 to 24, times the mass of the satellite, which is 425 kilograms, and this is divided by the distance in between the satellite and the center of the Earth. And this distance is given by 2 times the radius of the Earth. Then we have 2 times 6.38 times 10 to the 6 squared, and this results in a gravitational force of approximately 1040 newtons, which we can write as 1.04 times 10 to the third newtons. It means that the Earth is exerting a force on the spaceship, attracting it, and at the same time the spaceship is attracting Earth with a force of the same magnitude but opposite direction. So, on the second item, we have to calculate what is the magnitude of the gravitational force exerted on the Earth by the satellite. It happens that the gravitational force exerted on the Earth by the satellite has the same magnitude as the gravitational force exerted on the satellite by the Earth. There is a symmetry in the gravitational force. So again, we have 1.04 times 10 to the third newtons. On the next item, we have to calculate the satellite's acceleration. For that, we have to use Newton's second law. Let me choose this to be my reference frame, and I will call this axis x. Then, the net force exerted on the satellite is given by the satellite's mass times its acceleration. Therefore, the acceleration of the satellite is given by the net force being exerted on it divided by its mass. The net force exerted on the satellite is the gravitational force that is being exerted to the left. Then, we have minus the gravitational force divided by the mass of the satellite, and this is minus 1.04 times 10 to the third divided by 425, which results in an acceleration of approximately minus 2.45 meters per second squared. Note that the minus sign indicates that the satellite is being accelerated to the left. Then, for the last item, we have to calculate what is the acceleration of the Earth. Again, we have to use Newton's second law, so the net force being exerted on the Earth is equal to the mass of the Earth times its acceleration. Then, the acceleration of the Earth is given by the net force exerted on the Earth divided by its mass, which, again, the net force exerted on the Earth is the gravitational force, but this time it's exerted to the right, so it's positive. We have 1.04 times 10 to the third divided by the mass of the Earth, which is 5.98 times 10 to 24. This results in an acceleration of approximately 1.74 times 10 to minus 22 meters per second squared.